So what we're looking at with section 10, actually chapter 10, is we focus on square roots. And you'll see, if you look through the book, or if you listen to any of the videos, maybe from section 10.3, they talk about cube roots or fourth roots, but we focus on square roots. So what do I mean by a square root? So it is the opposite of squaring a number, is taking the square root. So as an example here, so if I squared a number, I get 9, but if I do the opposite of squaring a number, I get 3. Okay, so that would be the square root. A number b is a square root of a number if b squared gives you the number, right? In order to find a square root of a, you need a number that when squared equals a. These are different ways to talk about the square root. And a is a non-negative number. If a is a non-negative number, the non-negative number b, such that b squared is equal to a, is the principal square root of a. And it's denoted b is equal to the square root of a. So I want to talk about this principal square root a little bit more. When you look at the square root of 9, we'll just stick with the square root of 9. You're looking at for a number when it is squared gives you 9. A number when it is squared gives you 9. Well, I know that 3 squared gives me 9. But also -3, if it's in parentheses squared, also gives me 9. Now in math, we have to have exactness, right? And so it's important. So what this principal square root, this part right here, is saying that if you use that square root symbol, the square root of 9 is going to be the principal square root. And so we say it is going to be equal to 3. Now, how do you get the -3? Because that's an important number as well. Well, to get the -3, I will say, and we put that negative sign out front. So negative the square root of 9 is equal to a -3. So that's how you would represent or get the negative square root of -3. Okay, so when it's just the square root of 9, we're always looking for that positive value. Couple more things. Every number has 2 square roots, one positive and one negative. Again, but that square root sign means the principal or the positive square root. And one last thing is the square root of 0 is 0. So we need to put that in the definition. So we'll list some square roots. List some. Okay, well, we have some, let's look at some nice perfect squares and what their square roots would be. As an example, if we were going to list some, I know that the square root of 1 is 1. I know that the square root of 4 is 2. So it's nice to know what these perfect squares look like so that we know what the square roots are. The square root of 16 is 4. Now remember, it's the principal square root of 25 is 5. Let's do a few more. All right, the principal square root of 36 is 6. And I'm really doing this so that we can take a look. This is a good exercise to do because then when we get the square root of these perfect squares, we'll know how to simplify. All right, I'm going to go a little crazy here though. So I'm going to stop the list. What if we look at some fractions? Huh? Well, I'll tell you, if we have the square root of some fractions, like 64 over 81, well, I want you to notice that 64 is a perfect square and 81 is a perfect square. So the fraction that we're going to do, the fraction that is the principal square root of 64 over 81 would be 8/9. Okay, so when you are given a fraction, just say, okay, just kind of like, a fraction, right? You bring it in and you say, okay, is the numerator a perfect square? Is the denominator a perfect square? And can I take the square root of this? All right, so we can continue to find a lot of these. We'll do one more of those. How about the square root of 121 out of 144? Okay, these are getting serious, right? They're getting big. Well, the square root of 121, that actually is a perfect square, 11, and the square root of 144 is 12. And we're going to be working with simplifying these radicals or these square roots more. All right, so let's go ahead and take a look at just, we could continue the list and write on forever, but we're going to move on to some examples. And I just want us to take the principal square root of some numbers. And when I look at the square root of 25, now remember that means the principal square root. The principal square root or the positive square root of 25 is 5 because 5 times 5 is 25. And we can look at that. Okay, we're going to check, if you will. 5 squared equals 25. We don't always have to check these, but the checking is the reason that it is true. And the principal square root. Go to B. The square root of the fraction 1 over 81. It's easy to get overwhelmed with fractions, but when I look at this, all right, the square root of 1 over 81. Well, I know that 1 is a perfect square, and 81 is a perfect square, and the square root of 81 is 9. Okay, so as long as it's a perfect square over a perfect square, we can take the square root. All right, the other B, I guess this should be a C here. The square root of 400. Okay, these numbers are getting pretty big. But when I start thinking about this number though, the square root of 400, well, 400 is 20 squared. Okay, it's 20 squared. Well, the square root of 20 squared is 20 because it's equal to what squared gives you that number. And since 20 squared gives you 400, the principal square root of 400 has to be 20. And we could, again, do these all day long. I could do a D. What is the principal square root of 49? Well, 7 squared gives me 49, so the answer is 7. I could add that negative in front and say, okay, well, what is negative the square root of 49? Well, I'd bring that negative along. And then the square root of 49 is 7. So that's how we would get the negative square root of 49. All right, so any questions? Okay, great. Well, let's go ahead. You can always ask questions. All right, so evaluating. When you are evaluating, right, we're going to be simplifying square roots. And you need to handle a square root as if there's already a set of parentheses around it. So we are going to simplify the expression, take the square root, and then any other operations. As an example, if I were to read number 1, I would read it as -4 times the square root of 36. All right, so I'm going to do -4 times. Well, what is the square root of 36? The principal square root of 36. It is 6. So -4 times 6 gives me -24. That would be my answer. Okay, right below it, we have another expression. And I actually want to bring in these two, number 2 and 3 on the left. The reason I want to bring them in is you see a pattern, they look a little similar, but they're actually quite different. We have to simplify each square root before we can combine it with another value. As an example, with number 2, the principal square root of 9 is 3. The principal square root of 16 is 4. 3 plus 4 is 7. And that would be my answer. Now the difference between 2 and 3 is that in 3, the 9 plus 16 is under the same square root. So I can't break them apart. I have to keep it together. And so I simplify that radical first. All right, well, I know that the square root of 9 plus 16, well, that's going to be the square root of 25. Okay. And then the square root of 25 is 5. So notice we got different answers. And the conclusion I want you to make from this is that the square root of A plus the square root of B does not necessarily equal the square root of A plus B. We can't say that they are going to be equal. So we have to simplify first, and then we can combine terms. Let's go on to number 4 up here. All right, so number 4 does follow that we have an expression underneath the square root sign. If I were to read this, I would read it as the square root of the quantity 64 minus 4 times 7 times 1. Now, to simplify this, I know with order of operations, I have to take care of the multiplication before the subtraction. And 4 times 7 times 1 is 28. All right. Now, we take care of that expression before we take the principal square root. So the square root of 64 minus 28, well, that'd be the square root of 36. And the square root of 36 is 6. And that would be the answer. So simplify what is underneath the principal square root before you take that principal square root. And then with 5 and 6. So take a look at 5 and 6 just for a minute. Go ahead and do them and we'll come back and talk about these in just like 30 seconds. All right. 5 and 6 are handled differently. We have to simplify each square root in 5 before we can combine the terms. So the square root of 36, the principal square root is 6. The principal square root of 64 is 8 because 8 times 8 is 64. And when you add 6 and 84, you get 14. So 14 would be our answer. And with number 6, now 36 plus 64 is under the same radical. So the first thing we have to do is combine like terms. And we get 100. The principal square root of 100 is 10. So you have to be careful and remember to simplify under the square root before you take the principal square root. Are there any questions? Okay. Now, a good thing to do is to list the perfect squares because the perfect squares, and we'll use them a little bit here. Perfect squares have the nice rational, meaning it can be expressed as a fraction, square root. So when we look at some perfect squares, we can look at 1, 4, 9, because 3 squared gives me 9, 4 squared gives me 16, 5 squared gives me 25, 36, 49, 64, and we can continue. It's always good to see them. Well, a few more properties about the square root is the square root of a perfect square is rational. I just mentioned that, didn't I? All right, and so it's good to know or have some familiarity with the perfect squares. The next property, the square root of a number that is not a perfect square is irrational. What is irrational? So an irrational number has a non-terminating, non-repeating decimal. Pi is probably, I would say pi is the most famous irrational number because when you divide out pi, if you will, you get a non-repeating, non-terminating decimal. The next property, the square root of a negative number is not a real number. So what we'll say for this, because this can come up, we're just going to say it's not a real number. Okay, it's that simple. So I want us to also, so those are the 3 properties. The square root of a perfect square is rational. The square root of a number that is not a perfect square is irrational. and the square root of a negative number is not real. So let's go ahead and then just practice a few. I want to estimate a square root. Now, to estimate a square root, and actually I'm going to bring up my calculator. I have one with me. This is the only time I really like using calculators in class, but let me go ahead and, okay, so estimating a square root. Estimation is a great skill. It'll help us just, that approximation. How do we approximate a square root? Well, what we're going to do is we're going to look first at the square root of 7. So I want to look at the square root of some perfect squares. So if I have the square root of 7, and I'll show you what I'll do. Well, that's going to be, 7 is between 4 and 9. Now, why did I pick 4 and 9? Well, look at here. They are perfect squares, and they're going to have, by the way, hold on. I'm going to rewrite that because they're not equal, okay? What we can say is, since 7 is between 4 and 9, then the square root of 7 has to be between the square root of 4 and the square root of 9. Well, the square root of 4 is 2. The square root of 9 is 3. So we know the square root of 7 is between 2 and 3, and it's almost directly in the center, right? It's a little bit more than directly in the center, a little bit more. So what I'm going to do is I'm just going to estimate that the square root of 7 is approximately, so it's a squiggly equal sign, it's approximately 2.5, because it's almost in the middle, very close. Let's take a look at another one. The square root of 3. Well, what I can say about the square root of 3, well, first, 3 is between 1 and 4. I picked 1 and 4 because they are consecutive perfect squares. Well, this means that the square root of 3 is between the square root of 1 and the square root of 4. Well, I know what the square root of 1 is 1, and I know that the square root of 4 is 2. Now, 3 is a little closer to 4, so I need to pick something between 1 and 2. I'm going to pick something that's just a little closer to 4, not even much closer. I'm going to say the square root of 3 is approximately 1.7. I'll just guess. All right, one thing I didn't do is I didn't use my calculator. So I'm going to go ahead and do that. I need to go to, I don't know this calculator very well. No, I don't want that. That's what I want. So I'm going to do the square root of 7 first. Go back up to the first example there. And the square root of 7 is 2.64. Okay, so that is really close. It was a little low, but that's fine. Again, it's an approximation. Let's take a look at the square root of 3. So the square root of 3 is equal to 1.73. Okay, I was really close there. I was within 3/100ths on the second approximation. All right, so when you are working with square roots, it's just, we want to be able to approximate. Let's do one more. Okay, this is it actually does come in handy. I want to do the square root of 133. All right, just to make sure that you know that answers are correct. So one thing I would say is 133 is it's less than 144, which is the square root of, or is 12 squared, and 121. All right, well, that means that the square root of 133 is between the square root of 144 and the square root of 121. And then I know the square root of 121 is 11. And I know the square root of 144 is 12. All right, so it's going to be between 11 and 12, and it's almost right in the middle. It's almost right, smack in the middle. So I'm going to say 11.5. Okay, the square root of 133 is approximately 11.5. And let's just go ahead and calculate that on your on the calculator. And when we do that, oops, let's put that out. We get 11.53, almost right in the middle. All right, any questions on approximating? All right, so let's go ahead and take a look at a property that we really only use for this section in the book, but it is really good to know. And that's when we use variables with square roots or variables with perfect squares. And well, let's just go ahead and read it. It's the square root of variable expressions. Now, what we need to remember is when we're talking about with the square root symbol, it's the principal square root and it's the positive square root. But variables can be anything, right? They can be positive numbers, they can be negative numbers, as long as it's in their domain. And so we need to make sure that when we communicate our answers, that we are communicating that it would be the positive variable value, not the negative variable value. So we're going to use the absolute value sign. Okay? So the square root of a squared is equal to the absolute value of a. And just some examples. Number one, the square root of 7 squared. It is true that this is the absolute value of 7, but that's just equal to 7. Okay, but so since 7 is already positive, you'll get the same value out. Excuse me, but number 2, the square root of the quantity negative 15 squared. Now, the quantity negative 15 squared, right, is 225. It's positive. It's positive, but it's the square root of something squared. Now, this is going to be the absolute value of negative 15, which is equal to 15, because we're not taking the square root of a negative number. We know we can't do that. What we're doing is we're squaring that negative first, which makes it positive, and then we're taking the square root. But we can say the square root of negative 15 quantity squared is the absolute value of negative 15, which equals 15. All right, so what we'll do is we're going to use that with our variables. And when we look at the square root of x squared, we don't know if x is a negative 3 or a positive 3, a negative 7, a positive 7. We don't know that. What we do know is that the square root of x squared has to be a positive number. So when we look at the square root of x squared, it is going to be the absolute value of x, the absolute value of whatever is being squared inside. We can look at number 4, the square root of 3x minus 1 squared, quantity squared. The whole thing is squared, right? Well, the square root cancels out the square. They cancel each other out, but we need to make sure we're grabbing the principal square root. So we are going to say that the square root of the quantity 3x minus 1 squared is equal to the absolute value. Make sure those lines look big enough. The absolute value of 3x minus 1. Now this can come in handy also when we look at 5. Now at 5, you may be like, what do I do with 5? Because it's the square root of a squared minus 12a plus 36, that whole expression. When you look at something like this, see if you can factor it. And often what we can do is we can factor it into something squared. And if I did factor this, and you can check my factoring by multiplying, by FOILing, but this does end up being the square root of the quantity a minus 6 squared. And by definition, the square root cancels out the perfect square, and we are left with the absolute value of a minus 6. The absolute value of a minus 6. So we have a few more here. I just want you to practice finding the square roots. I'll give you a minute. In fact, I think it's a good time for a break. I will leave these up just on the screen. I'll bring them back up on the screen for just a moment, but we're going to do 5-minute break. All right, so that's it, 5 minutes. Feel free to work on these, and we'll come back and we'll compare our answers. Push the wrong button. All right, so let's go ahead and jump back in to our notes, and we'll go over these examples. So talking about principal square root, looking at number 6, the principal square root of the quantity -10 squared is the absolute value of -10, but we would write this as just 10. So we drop the absolute value signs. For number 7, the square root of 9 squared is going to be 9. Right? We don't even have to take the absolute value. We know it is going to be 9. For number 8, the principal square root of the quantity 2x plus 1 squared is equal to the absolute value of 2x plus 1. Number 9, the square root of x squared plus 10x plus 25. Well, we're going to have to do a little factoring. This does factor into x plus 5 quantities squared. So the square root of x plus 5 quantities squared is equal to the absolute value of x plus 5. And 10, the square root of x to the 8th. Well, we're going to talk about this more in the next section, that if you have an even exponent on a variable, it is a perfect square. So what do we do for the square root? Well, we take the exponent and we half it. We half it. Now, if it's x to the 4th, remember that any number to an even exponent will be positive. Any negative number to an even exponent is positive. Any negative number to an odd exponent is negative. So here we can actually simplify this further and say this is x to the 4th. And we'll talk about that later.